Well, let's now take up the next problem. That is problem 50 of your textbook. Here it says that the figure shows two blocks A and B, each having a mass of 320 kg. So you must note that mass M1 equal to M220 gram, that is equal to 0. Observation. Second point is connected by a light string. The string is light over a smooth light pulley. The horizontal surface on which the block A can slide is smooth. That means the friction here is zero. The block A is attached to a spring. This is the spring of the spring constant 40. So let us also note this K is 40. Whose either end is fixed to a support of 40 centimeter above the horizontal surface. That means the spring is supported 40 centimeter above, which is equal to 0.4 meter. Initially, the spring is vertical, find when the system is released. Find the velocity of the block A, that means this block A. At the instant, it breaks off the surface below it. In fact, let us see what is the question actually. Question is, this block B will start moving downward. Start moving downward due to its weight. And as it moves downward, and this block moves towards right, obviously this spring will get stretched. So let us try to draw a diagram. I think this is the best place to draw the diagram. Let us try to draw the diagram. What really happens? After a certain time, they say initially the block was here and the spring was here. This block will then get shifted rightward to certain distance. Let us say this distance is S. And with the pulley, this block bound by a same distance S, because there is only single pulley, same distance S. As a result, what will happen? This spring will be stretched like this. The spring is stretched, then what? Spring will try to compress itself to bring it to its neutral condition. So there will be a force in this direction, this force which is applied by the spring. And we know the force applied by the spring is Kx. If the spring is elongated by, say, by x, say this is 40 centimeter, that is 0.4 meter, and let's say this is 0. Plus x. Spring is elongated by x. If the spring is elongated by x, spring will apply a restoring force of kx. This kx has a vertically upward component, and if this angle is theta, this angle is kx cos theta. And this kx also will have a component in this direction, which is kx sine theta. Now, other forces. Other forces is the tension applied in this direction and the gravitational weight force mg of this body. This body. This body is A. This body is also A. Let us, once we have identified the forces, now let us equate the forces in two perpendicular directions. If we start equating, first let us find out what is cos theta. Cos theta is, if this is 0.4 and this is 0.4 plus x, then cos theta is equal to 0.4 divided by cos x. This is cos theta. Next, this force mg vertically downward and the spring's restoring force kx cos theta vertically upward, they have to interact, they have to oppose each other. So these forces are same. So we write also kx cos theta equal to g. That then from kx cos theta equal to mg equal to, from here we shall find it like this. K is given 40. K is given x we do not know. Cos theta is equal to 0.4 divided by 0.4 plus x. This is equal to m is given 320 gram, which is 0.32 kg, 0.32 kg. G we consider 10, right? From here we 40 multiplied by 0.4, that means 16x divided by 0.4 plus x. This is equal to 0.32 multiplied by 10 is equal to 3.2. From here, after one or two steps, you can find out that x is equal to 0.1 unit is, of course, meter. Value of x we have got. Since we have got the value of x, we can easily find out the value of cos theta. Therefore, we write, therefore, cos theta is equal to 0.4 divided by 0.1, which is equal to 4 upon 5, which is equal to 4 upon 5, which is equal to 0.8. By the way, you may remember cos 37 is 0.8. These two things we have done. Also, from this triangle, we find that this distance, now we are trying to find out s. S square plus 0.4 whole square is equal to this diagonal score. So let us give a name. This, let's say this is A dash, this is A, let us say this is O. So from the triangle dash O, from this triangle, we get S square plus 0.4 whole square is equal to 0. x whole square. Now the value of x, value of x is 0.1. So this is equal to 0.5 whole square is equal to 0.25. From here, you can easily find out the value of s. If you calculate, value of s will be 0.3 meter. I am skipping the small calculation part because otherwise you also will become bored about it. So we have got the value of s, we have got the value of cos theta, we have got the value of x, everything we have got. Now let us go to next part. We divide the board here. We go to next part. What is the work done by the gravity? Gravity is this body comes down by a distance s. Work down or done us 0.32 into G10, and it has traveled a distance s which is equal to 0.3 meter, multiplied by 0.32. This is 0.96. 0.9 work done. So gravity pulls this body B and B comes to B dash. Gravity pulls this body and some work is done by the gravity. And that means this potential energy of B drops down by an amount of 0.96 joule. Potential energy is used in two ways. One way is to stretch the spring. Another way is to shift the block. Now, in this calculation, we can easily find out what is the work done to stretch the spring, what is the work done to shift the block A from A to A dash. If we calculate that, then what is the energy? Let us find out energy spent stretch the spring equal to half kx square. We all know is half k x square equal to half. Value of k is given here, 40 Newton. Value of k is 40. And x is also, we have found 0.1. So this multiplied by 0.1 whole square. Calculate this, you will find 0.2 joule work has been spent in, energy has been spent in stretching the spring. Now, I think it is better to write for your memory or your work afterwards. Potential, we write potential energy lost by E will be equal to energy spent, or you could also write work done, energy spent to stretch the energy spent to stretch the block A plus kinetic energy gained by block A plus kinetic energy gained. So what is the kinetic energy gained by A? So kinetic energy A by A is equal to gravitational potential energy lost is 0.96, 0.96 minus energy spent in stretching the spring is 0.2, 0.2, which is equal to 0.76 joule. So this is the kinetic energy of the body. And here, both A and B are moving, right? So let us not forget this. Both A and B are and say velocity is equal to P. That means half m v square plus another body half m v square is equal to 0.76 joule. That means mv square equal to 0.76 joule. M we know is 0.32. So we find v square is equal to 0.76 by 0.3 v square. This is, if you calculate with a calculator, you will find it is 2.375. So what is the velocity? So velocity is under root of 2.735. You will find this is 1.5411 meter per second. So what we found, when the body B pulls body A downward, the spring keeps on stretching. And a component of that restoring force kx cos theta, it opposes the mg. But due to the pull, it starts acceleration, because if there is a net force, there will be an acceleration. And it will finally reach a velocity v when theta will be so large. Theta will be so large. In that case, if theta increases, kx cos theta decreases, though x increases a little bit, the magnitude of x is very small. So kx cos theta keeps on decreasing as the body A comes to right. A point will come when kx cos theta can no more counter mg. And that is the point the body A will be lifted up from this step. So this is the answer. Okay. Shall go to the next problem. Now we shall go to the next problem.